Okay, in this video I just want to show you really quickly how to add pressure brake tanks to an EPANET model. This is specifically for designing gravity flow systems. Regardless of what you may have heard, EPANET does work to do that. So first you'll have your reservoir, which could model a spring, as in the case that we're using it for an Ecuador or a lake or a river, what have you not. You got a couple of users. And you go ahead and connect these together. And let's say that our spring starts at 70 meters above sea level. That's just arbitrary. It's the difference that'll matter. And that our users are down at, let's say, 20. Let's see if we can make this work real quick. And let's say both of them are using about 0.2 liters per second, which is an okay amount if they want it for drinking and washing and all that kind of stuff. And let's say the length of our pipes should be both 100 meters. They're both 90 millimeters in diameter, and they're plastic, so they have a roughness coefficient for the Hazen-Williams formula of about a 140. So anyways, those are those details. We run the model, and here we go. You can see that because of the difference in heights between this 70 meters and this 20 meters, that's a 50 meter drop. That is too much pressure, and we're getting over 3 bars of pressure or over 30 meters of pressure. So we want to add a pressure brake tank, and it's pretty simple. You just take that one, you delete it, you throw in a tank, and we give it a little volume. The initial level that the tank is at, let's just say it's at 0.3 meters. The minimum level where the outlet is 0.2. The maximum level is 0.9. And let's say it's 1.5 meters in diameter. And these two combined is approximately a couple 100-gallon tanks, so not too big. And then we're going to add a pipe from the reservoir to the tank, and from the tank to this person. And we need to make sure that the lengths of those two pipes equals the lengths of the other one, just so it's kind of, showing the difference between one user 50 meters down, 100 meters away. Same thing over here. So 50, 50 equals 100. Okay, let's run this up and see what happens. Alright, errors were generated, negative pressure. That's probably because I screwed up some tiny detail, which is I never gave an elevation to the tank. So let's put the tank at 30, just somewhere in the middle. Actually, let's put it at 40 and see if it works. Run was successful. So this turns green. The pressure is back in a normal range for, faucet tap, 10 to 30 meters. The nice thing about this is that you can kind of play with where you want your elevation of your tank to be. So if we put it closer to the reservoir, say at 60, and we run it again, you can see that it's not in the appropriate place, and still in this line enough pressure builds up so that it's too much. So we'll put it back at, I think the number we had it at was 40. Run it. It's back to green. We can even put it a little bit lower. I bet you it will still work. Run it. Still green. So you can see you can play with this. Find an elevation along your topography that will work to make the pressures good, as well as it'll work in terms of it's easy to build there, because you might have a range of places you could build it, and this will give you a little indication of where you can put it, where it'll still work. So that's it. If you want to do a pressure brake tank, essentially just add a tank and fill these things out as I've shown you, and you're on your way.